that's the energy saving. Because of the good settling characteristics of the sludge, you can do everything in one tank, and you don't need to pump around the sludge. You don't need to mix anoxic and aerobic zones. You don't have the energy for the secondary clarifier. So all this mechanical energy which you normally spend at an extended nitrogen removal plant is not needed, and you can do that in one tank. Save space, but then also energy, and that's mainly the mechanical energy. And because you have a batch process, you have also better process control. So there is development towards getting granular sludge into continuous processes. If you ask my opinion, for a green field site, this makes no sense. For an existing plant, it can be advantage that you can reuse the existing facilities and have a higher volumetric conversion capacity. But from energy savings, you will not save the energy because you still then need all these pumps to pump it around in the continuous process. Actually, here on the bottom, you see a picture of the 100th Nereda plant, the technology from Royal Haskoning DHV implemented in Florida, which was announced just a month ago. And that means that at least the technology, having 100 references worldwide, is established. And I'm looking forward to all kinds of other implementations in different form than in the Nereda. So around production of energy, that has been investigated in the Netherlands a long time and many other places. On this map you see all the wastewater treatment plants indicated which are more or less energy neutral or net energy producing installations in the Netherlands. And that's partly done by improving the digester, either existing digester or moving to a plug flow digester, which will optimize your treatment plant. Sometimes this is done by importing food waste at the treatment plant and co-digest it. My opinion there is that this is not making a plant energy neutral. This is just importing energy, converting it into biogas, and then claiming that with that biogas you get energy neutral. That biogas could also have been produced somewhere else. But it is by people considered as getting energy neutral. But besides the biogas, which is very much the focus very often of the wastewater treatment groups, we also would have to think about effluent heat. Now, and also whether we anyway want biogas. I already indicated that producing biogas at the treatment plant has the risk of significant methane emissions and having a negative carbon footprint, or a positive, whatever you want to say, but at least you might contribute to global change with the amount of methane you emit during the process if you don't take care. If in the end, after digestion, the sludge is going to an incinerator, it's good to consider if it's worthwhile to first digest and then incinerate or directly incinerate. This has much to do with local logistics, so there's not one solution. This depends a bit on local conditions, but it might be in the end, from a water treatment perspective, much more straightforward to dry the sludge, maybe using effluent heat for the drying, heat you retract from the effluent, instead of having first anaerobic digestion, then dewatering, or first even thermal hydrolysis to try to improve your methane production, and in the end going to incineration. My intuition is that going to incineration right away, if you can have an efficient drying process, is much more efficient than the digester in between. But you then generate the electricity not at the treatment plant, but at the burning facility. And in the Netherlands, there is an incinerator facility with about 33% electric energy recovery, which is very similar to a coal-fired electricity plant. And one efficient way of drying is making use of composting. That's about 1/3 of the waste sludge in the Netherlands is dried in this way. It's a very efficient way because you use the heat from oxidizing the sludge to evaporate the water. So it's composting at 70 degrees Celsius, and instead of wet air, you put dry air through the compost heap, meaning you evaporate all the water, and in this way dry, but not fully mineralize the sludge. If you do normal you mineralize, here you only dry, and at a certain moment the sludge is so dry, there's no biological activity anymore, and the rest of the organic carbon can simply be sent, for instance, to a coal-fired power station, mixed up with the powder coal to generate electricity in a normal electricity plant. So it's an interesting integration with the electricity industry. I mentioned already briefly effluent heat, because if we focus on trying to recover energy from a treatment plant, this is the treatment plant of Utrecht in the Netherlands. If they would have built, they did not do, but if they would have built an anaerobic digester, they would roughly have produced in biogas the energy equivalents of 1.5 to 2 megawatt. They instead have decided to just right away burn the sludge at the incinerator and use effluent heat. Now that effluent heat represents the amount of heat they recover from the effluent and bring into the district heating system of the local town is equivalent to 50 megawatt. So you can see that if energy recovery from wastewater is important, you should rather focus on effluent heat recovery than on the biogas systems and trying to optimize that. And of course, I know there are many more decision criteria than energy alone, but it's good to realize that. And in the Netherlands, in two of the largest towns, The Hague, or La Haye, and Utrecht, now there are effluent heat recovery facilities, both coupled to district heating systems, where then the effluent heat is very efficiently used. And in the summer, when there's no heat needed, that heat is stored in the aquifer under the treatment plant, and winter that heat is then pumped up and distributed to the houses. So there's a very efficient way also to store the heat temporarily. Now, finally, some remarks about resource recovery, because in the end, burning sludge and getting rid of the organic carbon is maybe an efficient way from the wastewater perspective, but from society perspective, the wastewater contains organic carbon. And from a sustainable society perspective, you should try to keep the organic carbon, as long organic carbon as possible. Because converting CO2 into organic carbon is a very inefficient, polluting process that's called agriculture. Now, I'm very much in favor of agriculture, but it has a lot of environmental problems.